All right, guys, you have made it to the last lesson in Unit 2. We are on Lesson 15B, Rational Numbers and Applications. Today, students will be able to find the product and quotient of rational numbers within real-world contexts. Students will be able to explain why a situation leads to multiplication or division, and this is important for many real-world problems like passing the unit test, because we all know that's coming up. This is our last lesson. All right, so let's look at the very first one. It says Dory can run 3.25 miles every hour. How long will it take her to run a race that is 6.25 miles long? So if we're thinking about what it says here, she can run 3.25 miles every hour. That means in 1 hour, she can run 3.25 miles. In 2 hours, she'd be able to run 6.50 or 6.5 miles. In 3 hours, we would be able to figure out she'd run 9.75 miles. So if we kept this going, how many hours would it take her to go? 16.25 miles. 16.25 miles, that's the same as 16 1/4. So we want to figure that out. So what are we going to do with these numbers? Well, this is one way. So you could always make a table. So this is called a table of values, and you'll be using this a lot in the next unit and next year. So you could always make a little table to figure this out. 1 hour, 3.25, 2 hours, 6.5, and you could just keep it going until you get to 6.25 or 6.25. But another way to do this is take those numbers and figure out what's going on. So her entire race is 16 1/4 miles. You know she's running 3.25 miles every hour. So that means we are going to be chunking this up into 3.25 little sections. So in other words, we're going to look for how many 3.25s we could take out of 16 1/4. When we're looking for how many times we can take a number out, that is division. So we were given the whole thing this time, and we're trying to chunk it up, and so we're going to take 16 1/4 and divide it. Well, I'm going to take that little fractional piece and change that into a decimal. Since this one's a decimal, it makes life just a little bit easier. So I'm going to take that 1/4 and divide it. 0.0. 4 goes into 10 2 times. That gives us 8. We have 2 left over. Add a 0, bring it down. 4 goes into 25 times. That gives us exactly 20. And so we would have nothing left. So that means that this little fractional piece is actually a 0.25. So we're going to take 16.25 and we're going to divide it by 3.25. All right, remember we cannot divide by a decimal, so we've got to move it. This one needs to move twice, which means I'm going to move this one twice. And so what I'm really dividing over here is 1,625 divided by 325. So this is one way that we can do this problem. Now we have to guess and check how many 325s do you think it's going to take? Well, my guess is going to be something close to maybe 5, I think would be a good estimate here. So let's see what we get from that. 325 times 5. That's going to give us 25, carry the 2, that's 10, and 2 more is 12, carry the 1, and 5 times 3 is 15, plus 1 is 16. Hey, that was a pretty good guess. That got us right to 1625, and that was a 5. I'll write the 1625 underneath here, nothing left over, and so that tells me that division is going to result in 5. Well, what does that mean to this problem? That means Dory is going to take 5 hours to run 16 1/4 miles. So it will take Dory 5 hours to run 16 1/4 miles. All right, so that's how we do this. Let's look at the next one. So the next one says, from 6 p.m. to 6 a.m., the temperature dropped 1.4 degrees each hour. What was the total change in temperature between 6 p.m. and 6 a.m.? So let's think about this. From 6 p.m. to 6 a.m., it changed 1.4 degrees each hour, and that dropped. So that means it's going to be a negative, right? So it's going down. So after 1 hour, let's see. Let's start at 6 o'clock. 6 o'clock, we don't know what the the actual temperature was. But we know an hour later, so at 7 o'clock, it was down 1.4 degrees from wherever it started. At 8 o'clock, it would have been down 2.8 degrees. At 9 o'clock, it would have been down, let's see, what's 1.4 plus 2.8? That's gonna be 4.2. Is that right? And so we could see that we keep going here, and we keep adding 1.4 for every single hour. And so if we know how many hours it's going to take, then we can just multiply that. All right, so how many hours are between 6 p.m. and 6 a.m.? Hopefully you already know that answer. It's going to be 12 hours in between there. 12 hours between 6 a.m. and 6 p.m. or vice versa. So how many degrees did it end up dropping if it dropped 1.4 degrees every single hour? Well, let's figure that out. That would be a multiplication problem. 12 times a negative 1.4 is how we're going to figure that out. I got the 12 because it was 12 hours in between those two times. So let's go ahead and figure that out. 12 times 1.4. Let's do that multiplying. 4 times 2 is 8. 4 times 1 is 4. We need a placeholder. 1 times 2 is 2. 1 times 1 is 1. Add those up. We get an 8 and a 6 and a 1 and 1 swoosh, so 1 swoosh in. So that's going to give me negative 16.8 altogether that it's dropping. All right, so it says over here, write an equation or draw a model. We did that. Estimate an answer. Sorry, we didn't estimate it, but find the exact answer. So the exact answer is after or between 6 p.m. and 6 p.m. and 6 a.m., the temp dropped how many degrees? It dropped 16.8. 16.8 degrees. That got pretty cold. All right, so wherever it started, it dropped 16.8 degrees from there. All right, let's look at Bridget. Bridget is making hair bows for her friends. Each hair bow requires 3/4 of a yard of ribbon. How many yards of ribbon will Bridget need to make all of the hair bows? Well, let's think. She's going to make 14 of them. We know one hair bow would require, what's it say, 3/4 of a yard of fabric. 2 hair bows would be twice that, so I'll just write that as 6/4 because that's easier to write. 3 hair bows we could write as 9/4, right? Because we're adding 3 more fourths every time. 4 hair bows, 3 more fourths from there would be 12/4. So that would be, what, 3 simplified? All right, so we could keep going until we get to all 14 hair bows, or we can look at what's happening here. So if we know each one is going to need 3/4 of a yard of ribbon, and there's 14 of them, then we're repeating that 3/4 14 times, and so that means we're taking that 3/4 and we're repeating that 14 times. So that's a multiplying problem. I'm going to go ahead and put this over a 1 and look to see if we can cross reduce it all. I look and see the 3 and 1, not so much, but the 4 and 14, we can reduce by 2. I can take out 2 groups of 2 from 4, and 2 goes into 14 7 times. And so that tells me I'm going to have 21 over 2, which is going to simplify to 10 and a half. All right, so what does that tell me? How many yards of ribbon will Bridget need to make all the hair bows? Bridget will need, so don't forget to respond in a sentence, Bridget will need 10 and a half yards of fabric. So she would need 10 and a half yards of fabric for all those hair bows. That's a lot of hair bows. All right, good. Let's go to our very last page. Are you excited? I'm excited. This is our very last page in the unit. Let's see what it's about. This says there are 18 apple trees in my orchard. If I can harvest fruit from 1 2/3 trees each day, how many days will it take to harvest all of them? All right, so we want to get to a total this time. We have a big total, 18, and we want to see how many groups I could take out of 1 2/3. Well, I know if I work for just 1 day, then I'm only going to be able to harvest 1 2/3 of a tree. If I work for 2 days, let's see, what would be twice that? So let's see, big by the bottom, add the top, that'd be 5/3. I'm going to write that as 5/3 because it's a little easier to keep adding 5/3 to 5/3 to 5/3. So after 2 days, it would be 10/3. After 3 days, it would be 15/3, which is 5. And so I could see that I'm going to have to keep going, and I'm trying to get to 18. I want to see how many times I have to do that to get to 18. And so since I said how many times, that is a division problem. We're trying to figure this out. So if you think of it that way, the entire group is 18 trees. 18 trees is the whole group, and each day I'm only able to harvest 1 2/3 of them. So I'm trying to break up this 18 into groups of 1 2/3 so that I can see how many days it's going to take to harvest the whole orchard. All right, so since I'm trying to break up 18 into smaller groups, I'm going to take that 18. Another way to say break it up into small groups is divide. So I'm going to take that 18, I'm going to divide it by 1 2/3. All right, so next, let's do our big by the bottom at the top. Let's change that to improper, make it easier to work with. I'll also put a 1 underneath that whole number. I'm going to keep the division for now and just rewrite this as 5/3. But now that we've rewritten it like a fraction, we know it's the keep, change, flip. So keep the 18 over 1, change to a multiplication sentence, and flip that second one to 3 over 5. All right, let's see if we can cross reduce. Let's see, nothing there, and so we go ahead and we multiply straight across. 18 times 3, I know is going to be 54. 1 times 5, I know is going to be 5. And how many groups of 5 can I take out of 54? Well, I could take out 10, but I would have 4 left over out of 5. All right, so that tells me 10 4/5. Well, what were they asking about? How many days will it take to harvest the entire orchard? We could say it would take 10 4/5 days, or that's about, if we need 4/5 a day, we might as well work the whole day. So, or about 11 days. All right, I want to use a recipe for muffins that calls for 3 cups of flour and 2 eggs. All right, so 3 cups of flour go with 2 eggs. And it says if I only have 1 egg, don't mind that. If I only have 1 egg, how much flour should I use? Well, this is a simple ratio problem. I remember doing this when we were in 6th grade, right? So a simple ratio problem. What they do to the 2 to cut it down to 1? Well, let's think about that. So 2 eggs goes with 3. Let's write this, you know what, as fractions. I kind of like fractions. So let's write them as fractions. 2 eggs, or 3 flour goes with 2 eggs. 3 flour goes with 2 eggs. 3 cups of flour goes with 2 eggs. As how many cups of flour goes with 1 egg? Okay, so if you remember doing this, looking backwards, what did they do here? Well, it looks like they multiplied by 2 to go that way. But I want to go the other way. I want to go from there to there. So let's divide by 2. And if I divide the bottom by 2, I'll divide the top by 2. And 3 divided by 2 is going to give me 1.5. If you want to see that, let's try it out. Let's see, how many 2's can we take out of 3? Well, that's a 1. I have 2. 1 left over. Decimal, bring it up. 0, bring it down. And 2 goes into 10 5 times. Now, we could have also written that as 1.5, but that tells me we would need 1.5 or 1.5 cups of flour for just 1 egg. All right, last part. remember how to do all this stuff. We're going to skip down a little bit because we're running out of time here. This is all review from our last few lessons. Remember, negative times a negative is a positive, and we can't divide by a decimal. So remember, we can change all fractions to decimals or decimals to fractions. Either way, let's keep reviewing this a little more tomorrow. Try your exit ticket today. Yay, math!